Okay, last lesson of Algebra 1. You ready?
No.
You're not ready?
Not ready, but I'll do it.
Okay, good, because we're ready or not, here we go. Completing the square. Some quadratic equations. What's a quadratic equation? What? No, not an equation that equals 0. An equation that has x to what power? 2. When x is squared, I have a quadratic equation. Okay? When it's the highest power. Okay, so some quadratic equations don't have solutions that I can take the roots of or that I can factor. Like when I look at it and I go, oh, this is prime. I can't factor it. And it has a b term in it, so I can't do the root thing. Sometimes that happens. Okay, and this is the solution on how do I find, there is a number that goes in for x that will work and solve it. Okay, but I have to do some manipulation to the equation to keep it equivalent and make it so I can factor it. Is that okay? So that's the idea when I'm completing the squares. We have to fix it so we can factor it. Okay? One cheesy tortilla chip. 1 cheesy tortilla chip. 2 cheesy tortilla chips. 3 cheesy tortilla chips. 5 cheesy tortilla chips. 8 math geeks should not be allowed anywhere near certain foods. What's wrong with nachos? There's only 12 left. Now what? Because the next number is supposed to be 13 in Fibonacci sequence. I didn't even know. 1, 2, 5, 3, 5, right? You add the two terms together. The bunnies. All right, now back to reality. Okay, solving quadratic equations, all right? I said some can't be solved by factoring, so we're going to do this thing called completing the square. We're going to make perfect square trinomials today. We're going to make them. Yes, yes. Not from the air, from numbers that are there. Okay? So, if we were given x squared plus bx, we would take half of the b here. Half of it and then square it and add that onto the end. So think about that for a second. When we had already given a perfect square trinomial, we had an x squared and we had a 9 on the end. What was our middle term? Remember we had to check our middle term to see if it would factor? If 9 was on the end and x squared was our first term, what would our middle term be? Listen carefully. Listen carefully. This, see where there's an x squared here? This was just x squared. See how this says b over 2 squared? Instead of that number right there would be a 9 plus 9. What would this number be? There is a number. What would it be? Remember when we had to check to see if we could factor it? Do you remember how we had to go the square root of x squared is x. The square root of 9 is 3. 3x times 2. Remember we had to double it, which was 6. So since I had to double it to get b, doesn't it make sense that if I divide it by 2, I will be able to square it and get that? If this was a 6x, couldn't I divide it by 2 and get 3? And then what's 3 squared? Do you see how it works both directions? That's what's happening here. Okay? All right, so we're given x squared minus 16x. What number do I need to add on to make my c part? What number do I need to add on to make this a perfect square trinomial? So what is b? Negative 16. If I divide it by 2, I get negative 8. And if I square negative 8, I get 64. Right? Is that true? Is all of those things true? Yeah? Okay, so now if I tack that 64 onto the end there, can I factor that? Isn't that a perfect square trinomial now? And I know how to factor that. It's a special. What's the factor? Yes, Sydney.
X plus 8 squared.
It would be x minus 8 squared.
How do you get that? The 7 above.
Well, the question says, what number do I need to add on to these two terms to make it a perfect square trinomial? And so that's where I came up with this little equation. Half of b squared is how I say it. Half of b squared. So half of b, half of negative 16 is negative 8. And if I square it, I get positive 64. This is when you're going to have to remember not to trust your calculator. If you put negative 8 squared without parentheses, right, it's going to be the wrong answer. Right? You have to put those parentheses in.
X minus 8 squared.
This is, if I did my ladder, I would have 64 on top and I'd have negative 16 on bottom, and it would be 2 negative 8s. So this means x minus 8 times x minus 8 when I say x minus 8 squared. I'm purposely choosing this number so this happens. Purposely choosing 64 so I can get this nice pretty factor. So far so good. Told you it was new. Let's do another one. Oh, b is a fraction. Is that okay? We don't like it, but is it okay? Why isn't it okay? It is okay. So can I divide 3/5 by 2?
No, wait. I'll try.
Yeah, let's do that. Okay. Since b is 3/5, oops, my clicker went away. I need to divide it by 2, which is like multiplying it by 1 over 2. That becomes 3/10. Then I square it, which becomes 9/100. It gets grosser and gross, right? But it's all true, yes? It's a nasty number. But if I add that on to these first two terms, I have this, right? And this is a perfect square trinomial. Okay, so I have a square for x squared, and 9 over 100 is a perfect square. It is, even though it's ugly. It's kind of like having two perfect squares, one over the other, but it's there. So what would this factor to? Yes?
X plus 3 over 2.
Squared. Yes.
I don't get how she
This number, because listen, if this, remember, the square roots of both of these is what's happening. I'm putting those square roots into there. You should already know how to factor perfect square trinomials. This going from here to here is not supposed to be new, the last two steps. The new part is coming up with the number.
So does the 3 over 5x just go away from there?
I factored it, so it doesn't go away. If I FOIL this, I get this. Remember, that's what factors are. When I FOIL this is x plus 3 over 10 times x plus 3 over 10. And when I FOIL that, first term is going to give me this, right? My outside term is going to give me 3/10 x, and I'm going to have another 3/10 x, right? So it's going to give me 6/10, which then simplifies to 3/5, and then 3/10 times 3/10 is 9/100. First outside inside last one, I FOIL that gives me this. That's how I check my FOIL or my factors, and make sure it FOILs to that answer given.
So how do you get that x plus 3? Like how do you get from that step to that step?
How do I go from here to here?
Yes.
The square root of this goes here. The square root of this goes here. And that is the square. Before I took the square, isn't that number? I really didn't have to drop it on down there. Okay. Let's do another one that's not quite so crazy, but okay. Even if I have a C, but it doesn't work, it doesn't make a perfect square trinomial, I can still make it happen. This is when I can't factor. When I get one and I go, oh, it's prime, I can't factor it, how in the world do I solve it? I'm going to move my C over, and then I'm going to add whatever that new number is that makes it pretty, I'm going to add it to both sides. It'll make sense after you do it, but I would write it down so you don't forget what to do. Some of you are, again, this is Kirk show. No difference between verse and each period, apparently. I would like put a little star by remember to add the same number to both sides, because in a minute that's going to become really important. And that's a common student thing to forget, especially when you're learning this for the first time. You'll forget. You'll remember how to do b divided by 2, and you'll square it, and you'll do all that work, and then you'll forget to do that number to the other side, and then your equation is not equivalent. Okay, so here we go. It says solve this. Okay, now if I subtract 9 from both sides, and I set it equal to 0, like I was supposed to in section 12.1, wasn't that what I was supposed to do? Set it equal to 0 and then factor. That cannot be factored. There are no numbers that multiply to give me -9 and add together to give me +8. There just aren't. Okay? So I'm telling you that ahead of time. I'm saying, Curtis, you cannot factor this, so let's not even try. Okay? I'm telling you that up front. But is there a number that I can make x squared plus 8x plus something to be a perfect square trinomial? No, the 9 is going to stay over there. I don't want it to come over because I can't factor it. Can't I take b, isn't this the b term? 8, right? Can I take 8, divide it by 2, then square it, and add 16 onto this and have a perfect square trinomial? Is that true? What? Yeah, I'm about to. So if now on the left side of the equation, I have made a perfect square trinomial that I can factor. What is it factored? Someone besides Sydney. You should already be able to know. I'm telling you it's perfect square trinomial, so you don't even have to test it. What are the factors? Jordan. X plus 4 squared. Yes. And then over here, I'm just going to add those together. Nothing fancy is going to happen, okay, on the right. I'm just going to add those two numbers together. Okay? Are you with me? Do you see all I did was simplify now? Factor, 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 duh. Down, there. Now, how do I'm trying to solve for x, for heaven's sakes. What do I do now?
Square root both sides.
Yeah, totally can do that now, right? Can I square root both sides?
Yes.
And then I'll get x plus 4 equals plus or minus 5?
Yeah.
Yay! That was what I wanted to happen. Something spectacular happened. But are you okay with completing the square? Are you okay with the number 16 just showing up from nowhere as long as I add it on both sides? It's equivalent. You guys learned that early on in the year, right? What we do to one side, we have to do to the other side. Yes? Yes, Ryan?
Yes.
Okay. So there I took the square root of both sides because Ryan told me to. And then I'm going to subtract 4 from both sides. And then I'm going to solve those two little numbers out, right? So -4 plus 5 is 1. -4 minus 5 is -9. So there are my two solutions to this crazy unfactorable problem that I was given. Yes, ma'am.
If you like factored it, why didn't you get those answers?
It can't be factored
Why?
because it's prime.
So
How?
you can't plug those numbers in the original equation.
Well, I guess you're right. In this case, you could factor it because it could be +9 and -1. You're right. There will be times where you can't, though. That's the point. I'm giving you ones that come out nice and pretty like this. When they don't come out nice and pretty, they can't be factored. You're going to have like radicals in your answer and stuff. Okay? So they can't be factored. All right. So make sure you check it. Right? Please check it. I know I don't harp on that, but this section's super important. When you square and square root stuff, sometimes the solutions don't work. All right, you got a step chart because you've never done this before and you're already freaking out on the inside because I can see it in your faces. Okay, number 1, write the equation in the form of x squared plus bx equals c. So if it's not already like that, that means your c is on the left. You want to move it over to the right.
That's trying to know one. Good might blow.
Oh my goodness, you have a flow.
Yeah. Like in-
Second step, complete the square by adding on b divided by 2 squared to both sides of the equation. And then factor that trinomial. Okay? There's more on the next slide, so you're not done yet. Because I created a perfect square trinomial, that means I have a binomial with a square on it. And since I have a binomial with a square on it, I know from last lesson I can take the roots. Yes? Yeah. Does anyone need more time on this slide? Okay, so that's the fourth step. Apply the square root property, and then solve whatever's left. Okay, what's the number 6? Check your solutions back in the original equation. So I didn't write that down on my slideshow. So number 6, check your answers in the original equation. Ready? And everyone box it out after 6 steps? Box it out. Okay, here we go. What's number 1 say on our step chart? X squared plus bx equals c. So what do I need to do? Is that in the right form? Nope. I need to add 3. Is that right, Noah? Is he right? Add 3 to both sides. Do I have the right form now?
Yes.
Okay, then what's the second step say? Someone else besides Ryan. Curtis, what's the second step say? Okay, so b is what here? -7. So -7 over 2 squared. Okay, I'm going to have another ugly fraction, aren't I? Right? Yes? No. Sorry, no decimals. No, we left decimals behind a few sections ago. I don't know if you noticed that. Actually, a couple part of the chapter. Okay. So now what do I do with that number? What's the third step say, Clay? Okay, so add that to both sides first, right? Then factor the trinomial, which is the left side of my equation. So what's it going to be? Addie, what do you think? Give a guess here. We know it's going to be a minus, yeah, squared. Do you see that whatever I put in here is what comes down into my factor? If you guys, the faster you can see that, the easier it's going to go. Because you're going to have this ugly, but you can go, that's -7 over 2. That's what I had to square. That's going to go in my factored form of the trinomial. Okay, now what do? Square root both sides. And then what? Add 7 halves. And I'm done. That's my answer. It is so ugly.
That is the most failed.
Now, what if I told you you had to give me this and the decimals? Could you give me the decimals? Yeah, this is the hard part, right? So what are the decimals? Does anybody know? Just anyone been working it? No one can put their calculator. But there it is. Those are the 2 solutions in decimals. Okay? Questions? Okay, before I go on to example 4, which is a fun word problem, I want to give you one to practice. So I don't have it in the slideshow, so I'm going to have to say it out loud. Yes, ma'am, you have a question?
Where's your 2 go?
The 2 go.
To both sides.
I don't know what you're talking about, sweetie.
7 over 2.
7 over 2.
You're supposed to add 7 over 2 to both sides.
And I did.
Yes.
Oh, this is 7 over 2 plus or minus square root 61 over 2. I just put them over the same denominator. Oh, yeah. You can separate your denominator, you just can't separate your numerator. No. When I have 1/2 plus 3/2, doesn't the denominator stay the same? That's what's happening there. Okay? You could wrote that different, sure. Okay, that's just simplified. You could have written it 7 over 2 plus or minus the square root of 61 over 2, and that is right. I would not count it wrong if you didn't write it like that. Okay? Deal? Okay, so before we start this one, let me give you one to try on your own. Ready? X squared minus 5x minus 14 equals 0. And the directions are solve by completing the square. That's the directions. Because we know another way to solve it, but right now I want you to solve it by completing the square. Remember, whenever you do the one side of the equation, you have to do the other. So what that b over 2 squared, you need to add that to both sides. Please don't forget that. Otherwise, it'll mess you all over. Okay, I'm about to start. Actually, okay, I'm going to start working it here. You should have 2. Quadratics have 2 answers. Nope. That's not how it works. Sorry. You mean too late, it's wrong? Too late, can't fix it. That's false. Okay, so the question was 2x squared minus 5x minus 14 equals 0. First step, I need to put 14 over there to get it in the right form, don't I? Okay, so the whole idea is I need something I'm going to add on to both sides. Coming up with that something is my formula, half of d squared, right? b is -5. That's the number, right? Is that what you guys got? Mm-hmm. Okay, so I need to put this in both places up here. Okay? I always do that, leave blanks, because then I won't forget both sides. That's just my own thing. Okay, so now, can I factor so it looks like this?
Yes.
Okay, so what does it become? Yeah, this becomes, right, this is what goes here. What happens over here though? Nonsense, okay, it's a fraction, so that means what, 28 over 2 plus 25, oh, that's 3 or 4. What's that? Which gives me what? Number? 6, 7, 8, 89. What was more? Oh, let me do it. Let me do my calculator. Where's my calculator? It would be 56. That's the first problem. And then that would be 10. That's better. Yes? Now what's the next step? Square root. Square root. Oh yay, look at what comes out. Alright, nice stuff here. Yes?
That's exactly right.
Okay, now what? Now what? Yep. Okay, so if it's a positive 9, I get 9 plus 5 is 14, divided by 2 is 7. If it's a negative 9 plus 5, that gives me negative 4 divided by 2, which is negative 2. Do I need to do that off to the side, or do you see how I got those numbers? Anybody? Did I lose anybody? Found you all? All right. To the word problem before the bell rings. If we are not getting through it, we're not going to get through it. I'm just warning you. So please make sure that you look over the example in the book, okay? Because the book does a really good job explaining how they get from step to step. So if you get lost, of course, you can always come before the bell rings tomorrow morning. All right, it's a garden, and we're multiplying, blah, 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 and we have an area. We have an area and one factor. Okay, here's your homework. Yeah, well, completing the square takes steps. Okay, you are not doing this without showing work. I mean, if there's no work, there's no credit because it's odds. Yes?
I don't like the odds.
What?
I like thinking more.
You do? Why is that?
Because you have odds, you have the temptation to cheat.
Well, if you give me a list of answers, you got a 0. So there's no temptation. Temptation gone. Yeah, we'll do completion, but I'm going to look for work. I'm going to come around and look for work. You have a quiz tomorrow. Quiz tomorrow. First thing in the morning.
What? Sugar and water.